Tarubo here. Today we are doing just page 3-24. And so just two problems here. The first problem has a couple different ways of solving it. And so I'm actually going to show the shorter way, but I will point out the um, more direct approach. So here we are told that this triangle is isosceles with base CB. So right away, we know that this angle and this angle are congruent. We also know that this side is congruent to that side, but we're just dealing with angles here, so it doesn't really matter there. And then we are told BH bisects, so we know this is congruent to this, and then this is congruent to this. And we actually do know all four of those angles are congruent to each other because they are supplements to congruent angles, right? If we were trying to write a proof. Now, the part that makes this problem where you have two options is the second part here where it says the ratio of angle 1 to angle 2 is 11 to 14. So I'm actually going to do it based on that, but I will kind of real quick talk. So GCB is angle 2, FBH is this angle out here. So we can set up an equation saying that 6x minus 2 plus 2 times 2y plus 15 equals 180, and then use the ratio of the sides with the x and the y. Say it equals like 6x minus 2 is in the denominator, 20y plus 15 is in the numerator, set it equal to 11 over 14, and we can do it that way. But again, the shortcut, the shorter way is realizing, okay, let's call this, and I don't want to use x because we're already using f, so I'm going to use a. So we know that this ratio is 11a, or these angles, angle 1 and angle 2, is 11a to 14a. Well, because of the bisect, we also know this is also 11a, which means I can forgo this. I don't need this. I can actually just say 11a plus 11a plus 14a equals 180 and solve that, which ends up giving you a equals 5, and that means measure of angle 1 is 50. If you go the other route, it's a lot more work. It's a system. If you want practice with systems, you can go the other way. You will still get the same answer. Okay, but this is kind of the, if you're paying attention to the ratios and straight lines, you can do this real nice and easy. All right. Then this last one here is triangle BAD congruent to triangle RAD. Why or why not? Well, we are given right angles, and then we're given congruent sides, and then we have this isosceles, or I'm sorry, this reflexive. It is an isosceles triangle, but if it, no, it's not a triangle, but it doesn't matter. We have this reflexive side. So when you look at this, you might initially say no, right? Because we have side-side angle, but because these are right angles, this actually gives us that last one we talked about before, which is hypotenuse leg. So, right, HL, we have the hypotenuses are equal, right? AD is congruent to AD by reflexive property. And then BD is congruent to RD by given, right? They gave us those two marks. So there's a hypotenuse, there's a leg, and it is congruent. So yes, they are. And this is an example of hypotenuse leg. You have to have those right angles, and then that becomes available. Okay. And the reason why it works is because if you know it's a right triangle, you could use a squared plus b squared equals c squared, and that would eventually tell us, like, this is the proof on why HL works. This would eventually tell us that this is congruent to that. And then you have side, side, side. But HL makes it so we don't have to do that. All right. Well, thanks for watching. Have a good day.